Let's clean up a bit before we continue with the next section. I will open up the basket blueprint. In the details, I will filter for collision. Remember, we had to enable simulation generate heat events for each of these, since those were set to false by default. Now, what if we want to set that to true by default in C++? If we were to derive from the C++ class again, some other blueprint class, or reparent the existing class and parent back to your C++ basket base, then those settings may be lost. This has actually happened to me quite a few times in the past, so it's a good idea to set that in C++ so that we don't have to come in here and check those each time. For this, I will actually close the editor, otherwise the modifications that we'll make may not reflect properly. So close that down and then back in Visual Studio, in the basketbase.cpp file, in the constructor, from the paddle1 pointer, for example, I will call set notify rigid body collision. This takes in a boolean, and so I'll pass in true, since we want that to be the default for that setting. I will duplicate that for each one of those paddles, build and run. Now if we open up that basket blueprint, notice that the simulation generate heat events is now true by default. You can even click the reset button for that. That will revert to the setting that we have set in C++, so this will now be checked by default. Back in Visual Studio, I will close off some of these files so that we can focus on your next task. We'll get back to the basket base later. In the source file for our game mode, in the handle apple lost function, if paddles lost is greater than 3, then we stop spawning apples, and we also destroy the remaining apples. There is some duplication in here, which we will clean up a bit. The get all actors of class is a slow operation, so we don't want to use that too often. Now in this section, if paddles lost is greater than 3, we could actually get away with only one invocation of the get all actors of class function. If you give it some thought, we can reduce this duplication by using inheritance and an if-else statement. We don't want to store a pointer to every actor in the level, that is unnecessary. For example, we don't need to store pointers to lights, cameras, and every other actor that we have in the level, only the elements of an apple tree, that is the apple tree itself, and then the apples. We can find all of the actors that are elements of an apple tree, so pointers to those objects in a pointer to an actor T array. This is where that basic understanding of inheritance comes into play. Back in the editor, I will create a new actor class. I will name this class Apple Tree Element Base. You can name that whatever you want, whatever makes sense for you. Since we have not used Apple Tree Base yet, you may want to use that. We won't actually do much with this class. We'll simply use that to set up an inheritance hierarchy. I will click Create Class, click to reload the project. I will open up the tree base header and the apple base header. Those are elements of an apple tree, right? So let's set up that relationship. I will include the apple tree element header in the tree base and apple base header files, making sure that the .generated header remains the last include in those headers. You can check the class name, since the additional prefix can catch you out if you don't keep in mind the fact that Unreal will prepend or prefix that additional A for an actor. Since we are in this file now, I will actually grab that class name, so I will just copy that, and then in the tree base header, I will make sure that your ATreeBase class publicly derives from the new AppleTree element base class. The same thing for our AppleBase class in the AppleBase header. I will close down the editor since I want to build this. Ctrl B to build this just to see if we get any errors, if we missed anything. That compiles fine. Now if apples lost is greater than 3, we can clean up this duplicated code a bit. I will delete this part where we destroy the remaining apples. Then we will use our AppleTreeElement base class to call the static class function on. I'll put that on a new line for readability so that you can see what is going on. Next, we want to rename this T array. I'll rename that to foundAppleTreeElements. Make sure to pass that identifier as the third actual parameter or argument to the getAllActorsOfClass function. We also want to update what we iterate through in the for loop. That will be our renamed t-array, found apple tree elements. I would like to note that we do not have to include the header for the apple tree element base class. You may want to pause the video for a second to think about why that is. Of course, this is because we include that header in the apple base and the tree base headers. So that is already included in those headers and will come in to this file. So there's no reason to include that again. We can actually declare the pointer in the check. For example, I will remove this, and in the if check, I will declare a temporary pointer to an atree base, and I can also do the cast in here, cast to atree base, and then pass in ptr, that pointer. Now we can use that in the body. I'll actually clean this up too now that we are here. What do we want to do? Well, we want to stop spawning apples as we have done before, but we do quite a bit in that single function, so for readability and maintainability, we may want to separate things out a bit. So I will actually separate things out into separate functions. We want to stop spawning apples, and then the tree should also stop redirecting. So we want to stop the tree, and then we also want to set should move to false. Otherwise, so else if the pointer is a pointer to an apple base, I will cast for that. Make sure to add the angle bracket there. I will add a comment on why we have this code here. We want to destroy those remaining apples. I'll remove the previous comment since the code should be self-documenting. That is once we have those functions set up properly. Let's implement the functions for this logic in the aTreeBase class. In the TreeBase interface, we already have a stop spawning apples function. I will declare two more functions, stop redirecting and set should move. Both will return void, but set should move will take in a boolean. I'll use the parameter name b in should move. Quick actions and refactorings and create those definitions. Save that, I'll open the file here shortly, create the definition for set should move, and then promote to document to open that file. We have the stop spawning apples function definition here, and we are doing everything in this function at the moment, so we want to move some of those statements out. Since we will clear the change direction timer in the stop redirection function, I will comment out the clear all timers for object statement, and uncomment this first one that I demonstrated previously. We do clear timer and then pass in the particular timer handle to clear. Remember, if we look at the interface file, we have these timer handles, the change direction timer handle and the apple spawn timer handle. Back in the TreeBase implementation file, in the stop spawning apples function, we want to clear the apple spawn timer, so I'll pass that in. In the stop redirecting function, we want to clear the change direction timer. Finally, we want to define the set should move function. I will remove the statement. We can now use this function to set that boolean instead. I will assign the in should move parameter to the should move member. With those functions implemented, we can go back to our game mode implementation, and where we have this to do section in the for loop in the if section, we can now use those functions. From that temporary pointer called stop spawning apples, then stop redirecting. And finally, we can use the set should move and pass in false. To recap this check, in the handle apple lost function, if apples lost is equal to or greater than 3, then get all actors of class apple tree element base, and for each one of those, if it is a tree base, then stop spawning apples, stop redirecting and set should move to false. Otherwise, if it is an apple base, call destroy to destroy those remaining apples. Let's build a run to test that. Back in the editor, close off that tab for now. Play and lose some of those apples to see what happens. That works fine as before. Next, I also want to set up a way for us to disable input. To demonstrate why, I will filter for basket in the outliner. I will hit play, and now it is quick and easy to select that actor, since only a couple of things will show up in the outliner, depending on how we filter. With that selected, notice that the transform location changes as we move the basket. That is, the Y variable changes. I will press the A or the D key to demonstrate. To move left and right, and notice the location Y variable still changes. So let's look at how we can disable input when it is game over basically. I will close off the editor and go to the basket base header. Remember that the basket base class handles the paddle destruction using that function that we have set up, but the function is not set up to handle the disabling of the player input. We actually already have a function for that in the pawn class called disable input, and we will actually invoke that from the basket pointer that we have in our game mode, but that requires that we pass in a pointer to a player controller. And so we want to fetch the player controller that is currently controlling this particular pawn. So I will declare a new function to get the basket player controller. That is the controller that is currently controlling this particular pawn. That will return a pointer to an A player controller, quick actions and refactorings, and create the definition. How will we find the player controller for this pawn? Well, I'll declare a controller variable, a pointer to an A player controller. Then I'll initialize that to null pointer in the constructor. Now, when is an appropriate time to fetch that player controller? Well, on begin play, right? Since on begin play that player controller should already be spawned and already exist. So in the begin play function, I will use the getController function to return the controller for this class. The getController function will return a pointer to an A controller. So we want to cast and make sure that is an A player controller. Assign that to our controller pointer. Now that we have that pointer, we can return that in our getBasketPlayerController function. Currently it returns null pointer, so let's return our controller instead. With that set up, let's go back to our game mode implementation. In the handleAppleLost function, if apples lost is greater than or equal to 3, then we want to disable input. Since at that point we will have lost our paddles, we will do a check here. If the basket pointer that we have set up previously, a pointer to the first player pawn, is not null pointer, and if our getBasketPlayerController function does not return a null pointer, then from that basket pointer, which remember is a pointer to a pawn, we want to disable input. So we use the disable input function, which again is a pawn function. The disable input function takes in a pointer to the player controller, whose input we no longer want the pawn to receive. I would like to mention that you can actually pass in the null pointer, and in that case the actor will stop receiving input from all player controllers. So from the basket pointer, let's use our getPlayerController function to return the controller for that pawn. I'm doing this setup since we can't always just pass in null pointer, and it's best to be explicit. With that setup, I will build and run that to test. I will filter in the outliner again to make selecting the basket easier when I playtest. Play and select that basket pawn in the outliner so that we can see the details on that. Lose some apples, and I will keep holding the A key down in this example when we lose that final apple here. Notice something strange happens with the location Y variable. It keeps going in the negative right vector as if we keep that button pressed, even though I have already let go. If I press the D or the right arrow button, for example, the variable does not reflect that, and that's because input is disabled at this point. Let's try that again. This time I will make sure to let go of the controls right before we lose that final apple. We can see that the location variable Y does not change. So how can we fix that issue where the value keeps changing in the case where we had a key down? Well, remember where we have the movement logic, it is in the tick function. With the disable input function, we can pass in the player controller, whose input events we no longer want to receive, right? But that does not mean that our tick function for that actor will stop firing. And in the tick function, as we can see here, we do some offset. So to fix this, we want to disable tick for this pawn actor. Back in the game mode, following the statement where we disable input for our basket, from the basket pointer, we can do set actor tick enabled and pass in false. I'd also like to demonstrate that you can set actor hidden in game and pass in true. You may need that at some point for your projects, depending on your pawn. We don't really need that at this point, so I'll comment out the statement. Build and run that. Filter for your basket pawn again in the outliner. I will play and then select the basket in the outliner. To test, I will keep pressing D as we lose that final apple. And if we inspect the location Y variable, that does not change. So that statement set actor tick enabled where we pass in false to disable the tick for the pawn seems to solve that issue. As demonstrated, we can disable the ticking for the pawn, and then that movement logic will not keep updating. But for an exercise, I'd like you to find an additional solution. This exercise should not be that difficult for you. You may just have to think a bit about what we are doing and what we are trying to solve. Back in the game mode, I will comment out the statement where we set the actor tick enable to false for our pawn. Then in the basket base implementation, in the tick function, we can use a check to see if the input is enabled, and only then execute the movement logic. I will select this logic where we do the offset, and then right-click, select snippet and surround with to surround that with an if statement. I will use the input enabled function, which returns a boolean, whether the pawn's input handling is enabled. With this setup, we will only execute this movement logic per tick if the input is enabled. Remember, in our game mode, when apples lost is equal to or greater than 3, we disable input on that pawn. So let's save those changes and recompile to test. I will play and select the basket in the outliner so that we can inspect the transform. I will keep the D button pressed as I lose that final apple, and the location Y variable does not keep changing as it did at first. Back in Visual Studio in our game mode, I will uncomment the statement where we set actor tick enabled to false, that is for our pawn. At this point there's no reason for our pawn to tick, since it is game over basically. This statement and the check for is input enabled in the tick function of basket base will ensure that we don't get unnecessary computations while we are in that process of cleaning up after the player has lost the game. And with that, we are going to wrap up this section of the project. I know I covered quite a few things in this lecture, but hopefully you find this useful, and so I'll see you next time.